I think, yeah, it's just that the policy isn't good.
What is this?
It's still the same thing. It's just, it's learning. So it just,
Like,
Wait a second,
essentially,
show the previous one. What is this here? No, the previous one above. No. No, what did the averaging show to you?
this is the average of the optimal actions over all the episodes. Although I didn't do what he said, and like I didn't start it at 100, so maybe that would help.
Yeah, but why the order size is so small? It's unbelievable.
Yeah, sometimes it just starts. It starts in a really small place, and then it kind of gets stuck there.
so these are plots of these are the averaged graphs.
Yeah.
So it's like some of them are like going this way and some of them are going this way. So it's because overall it looks like it's a constant, almost a constant order quantity.
Yes, like in SS strategies, but if we will find the point S, it would be nice.
Yeah, if you plotted this on like a reasonable scale, it would just be a horizontal line.
For this purpose, we need to try different initial states or something like this, or to give more states, or maybe in this situation no jump. It depends.
No, this graph has no meaning at all because it says more inventory, more order.
Look, this graph is the constant mostly because this line derives from 1.26 to 1.31. 5 after
Oh, yeah. It's basically
it's almost
constant.
constant. This is a very good situation, but we have no jump here, and we find maybe some particular, maybe we find some very interesting. As I proposed, we need to use histograms or something like this to see that this function is constant.
Okay. So, Thomas, do you have any idea to try something else or?
I have like long-term ideas, but I don't have anything that.
Okay, so I'll be driving to Philadelphia now in half an hour, probably in 1 hour.
Yeah.
So you will be available by phone, yeah? Tonight.
Tonight, I should be.
Okay. So if you have something good, send it to me. If not, I just probably tell them, I don't know, show nothing, just give theoretical talk on this. I have two options. Or show the slide. Can you show the slide again that we started with?
Yeah.
I think Thomas make a very good job and he obtained a good results, but we need to maybe we need to find some situations when, for example, optimal policy have more than one value.
Pablo, we cannot solve the problem, the simple situation. You are trying to.
I think in these simple situations we can try to change some parameters. Also, I do not understand why alpha is so big.
What's so big?
Alpha maybe we may try to. No, this is my.
No, sorry, Thomas. When we change alpha from 0.99 to 2.9, does it change anything?
I think to.
No significant improvement.
When we change to 0.1.
Oh no, it's basically killing the problem.
Why? Alpha is the memory.
No, alpha is discount factor here.
No,
Oh.
alpha memory. No.
No, alpha is discount factor.
But what parameter is memory gamma?
Are you thinking
No,
of
there is no nothing is all these gammas and so on, the internal parameter for the algorithm.
I understand. I mean, in the algorithm, in the code.
Yeah, the update rate is tau. And
I mean, what's the tau? If we take tau, for example, I think it's very small. If we will take, for example, 0.1 or something like this, yes.
What tau you have now, Pavlo?
I had 0.005. I also tried out 0.05.
Pavlo, what do you suggest to use?
I mean to use another parameter for memory. If this parameter is very close to 0, we cannot. We have.
Okay, which memory you suggest to take?
Some more memory, for example, some more. I mean, in the after regression, if you will take, for example, 0.05, it will be a very small interval to learn, and I propose to take it, for example, to 20 times bigger, and to look what will happen with strategy and with.
Give the number, please.
A number he made 0.1.
0.1.
And now it's computing.
Thomas, did you start running?
Yeah. I made it so it doesn't start doing the graph until episode 100. So now it will start changing.
I'm not sure that it will give us a good result, but we will try. Also, we can take more states. For example, here we consider 6, and for example 10 or 12.
No, I think we have continuous state space here.
Yes, I understand, but we draw only 6 states, up to 6. And I mean that we may try to compute something for up to, for example, 10.
How the system decide that it is from -4 to 6? It is the system software decides, yeah?
The initial state is randomly generated uniformly between 0 and 5. So
I understand.
Yeah, so actually outside of 0 and 5, the graph doesn't really mean anything.
Maybe the jump if it exists can be on the next states after 8, for example, or after 10.
Yeah, here, for example, it's virtually 0, 2447, 24, it's constant.
Yeah.
Yes, but if you want to demonstrate something like SS strategies, we may try to find the jump point like in SS or something like more interesting. Here we have.
No, I don't want to demonstrate anything. I just would like to have meaningful results. And this one,
Here
it's
you
initial
have.
state.
Look, also I remember. Look, also, sorry. Also, I remember that in the average cost criterion, that are using usually in the solving of deep reinforcement learning problems, and here they can, no, I think that they can adapt this algorithm to that criterion. In the average cost, of course, you have a constant, and we see that the value is converging to that to some point, but the optimal strategy is also constant. It's very interesting. I think that we think about the discounted criterion, but we compute the average criterion, average cost criterion, because that algorithm, no, we need to verify it, but I think it is possible. Or what is this? Is this a value?
This is, yeah, this is the same as before. This is the average reward up to that point, like up to that episode, and then this is the average policy.
Policy is a constant, no, approximately
Yeah.
constant, and
Approximately constant.
the value is very interesting, but also I think this is a very good solution to this problem, but when we state this problem, the solution of it is not very interesting, because this is a constant, as in value, as in the policies. Because
Okay.
when we change the interval of the memory, we have the same answer. No, approximately the same answer.
Okay, let's try to wrap it up. Thomas, please show again slide 18 in the presentation, and let's discuss, should we change anything?
Yeah, I'd probably just not include the graph because it's not very accurate. Like, because the policy changes every time we run it. But I would instead just talk about the algorithm that we're using and what our plan is to solve this problem, because we don't have a complete solution up to this point.
Is there any way maybe to at least bring these numbers 20, 40, 30, 40 down somehow? Because this doesn't make much sense.
I mean, like, if we cherry pick, like, I'm sure I could find like a graph that looks good. It wouldn't be a very honest solution, because we're just
just find the graph that looks maybe slightly better or better, and try to have larger number of horizons and flow, maybe, if possible.
I mean, I can make the graph look like anything, pretty much.
Yeah.
Yeah.
Try to do the graph a little bit better, and I'll tell them that we just started and we have some encouraging results.
Okay.
I won't try to teach them how to work.
Yeah.
Okay.
Sounds good.
Okay, send it to me, and I'll see. Either present it with a graph or without graph. I need to submit it, send it tomorrow morning. Actually, they asked half an hour before the presentation, but they asked to do it in the evening if possible. Okay, so let's work, and maybe we'll speak on phone when I will be finished. Okay.
Okay. That's good.
Okay. Thank you very much. I'm sorry that we delayed, and I'm not sure about meeting in a week because we need to make progress with this paper, but I will be at the conference, so
Okay.
maybe a meeting in 2 weeks. Yeah.
Okay, let's do it.
Okay, yeah, I can, I'll just for now send out an invite for same time in 2 weeks.
Yeah.
Okay, yeah, that sounds good.
Okay. Thank you very much.
Thank
All
you.
right, thanks.
Thank
Bye-bye.
you. Bye.
Bad.